Okay, so I'll just start out now by saying we recorded the first attempt right after I had recorded the sort of talking head portion of my review. But we both messed up our separate recordings of the interview. And yeah, so this is the second attempt. So
Well,
and neither of
I'm
us
happy to
should be
help
messing
out.
up anything to do with digital audio.
No,
So it's very disqualifying for both of our careers. Uh,
absolutely.
but now let's do our best acting and pretend this is a spontaneous conversation and you haven't heard the questions before. And we'll see. So it's like 2 weeks later, and this is the second attempt. Anyway, thank you, Eelco, for doing this. I'm going to open my questions again that I had thankfully not deleted since last time. But so you are the one who got to name the company. How did you win the battle? Why is it Grimm?
Uh, it's a funny story, actually. We were working, the four founders, actually. The four founders are Bruno Putzijs, Pieter van Willenswaard, Guido Tent, and me. And we were working we were thinking about the name for the company for quite a while. And at a certain moment, I was late at the meeting because I had another appointment. And when I arrived, they told me, yes, well, sit down. And I hope you agree, because we together we agreed to call it Grimm Audio. And I was like, wow, why? Because it's a company of the four of us. And they told me, yeah, many companies that are successful are named after a founder. And the names Van Willenswaard or Putzis or maybe Tent, but Tent, Guido was already running a company called Tent Labs. And so that didn't make too much sense to have another tent company. And so they decided to call it after my surname. So it became Grimm Audio.
So
And I agreed.
I mean, yeah, and it's a little bit more. It it wouldn't have looked as good if you had insisted to be named after you at the expense of the others. No, it was the other way around. So it's a better look
Absolutely, yes.
for you. But so this is sort of the conclusion, or at least halftime point or whatever, for my review series of active loudspeakers. The LS1Cs are the fourth of the series, and I'll be reviewing other things for a while and maybe get back to active speakers in the future. And the question I've been posing is, are active loudspeakers the future? I am going to guess what direction you lean in with the answer to that. So what do you like? What do you think? Are they the future?
Well, I would say that not so much the future, they are the present. And they will be there in the future, but passive speakers will also be there in the future. In general, they pose different problems and also different solutions to the designers. Both are extremely complicated. It's not more simple with active, actually. But it offers more freedom to the designer. One thing, of course, is you need to have knowledge of all kinds of aspects, not just acoustics and drivers and crossovers, but also of amplifiers, and in our case with the LS1, of course, of the digital converters, and we do all our processing in the digital domain, crossovers, etc. So you have to have a lot of knowledge about digital DSP and not just, well, the textbook stuff, but also what matters for good sound quality, which is just as big an adventure as it is in analog, where you have to go through many years of experience and learning and testing and relearning before you have a grasp on the technology. And so that's not different in the digital domain. Maybe there is a risk that people don't experiment as much with sound quality stuff like bit depths, etc., in the digital domain as they do in the analog domain with selecting components and stuff. So that might be a challenge if you go into the digital domain. But if you are aware of it, I would say both strategies will offer you advantages and disadvantages. Now, the thing is that with an active system, and especially with a digitally controlled active system, you have much more freedom to solve some really nasty problems with loudspeaker design. The acoustics of the cabinet, they change, or they offer a certain character, acoustic character, the frequency response, phase response, etc., to a driver that's hard to correct in the analog domain. You will soon need more components that all have their sonic influence. And in the digital domain, you have more freedom adding equalizers, etc. Although at the same time, you have to be careful there. Come more to that later. But there is stuff that you cannot do in the analog domain ever, which is, for instance, the phase correction of a crossover. What we do in the LS1s is we apply that's what we call an inverse all-pass filter, which corrects the phase characteristic of the crossover. So the crossover in itself is already linear in its amplitude response, so all frequencies will come out equally loud, but there is a phase difference between the tweeter and the woofer. So the timing, so to say, of the high frequencies and the low frequencies not exactly as in the original signal. And in an analog system, it's impossible to correct for that. Maybe if you have a first order crossover, but then you have different problems. If you want to have less distortion, maybe play a little louder, you need a higher order crossover, and then it's unavoidable to have a phase shift in the crossover. Now, in the digital domain, you can compensate for that. And so you have more freedom in the digital domain. And of course, that means you will have an active speaker, because if you do the crossover in the digital domain, you will have a DA converter per driver, an amplifier per driver, and that's the definition of an active system. So is it the future?
But that also means, yes, you have more freedom. You have more freedom, but you also have more responsibility, like to allude to what you were talking about before, that you need knowledge of more
That's
domains.
a very important thing, yeah.
Because it's like the chain and its weakest link, and now you have more links.
So you need more knowledge, but of course, if you look at the full signal chain that you're listening to with a passive system, there's also a lot of gathered knowledge. You have people that designed the amplifiers, of course, the loudspeakers, and also the cables and the converters and the sources. And there's also a lot of knowledge involved in a passive chain, a passive loudspeaker chain, I should say. And so if you, as a company...
But they're distributed amongst more people.
Well, no, maybe not more people. Sometimes you have companies with just one guy developing amplifiers or so. And so we have a company here with a team of 12 engineers. No, not just engineers, but we have quite a big R&D team here. And so they have all their specialism. And so there's 4 people on software and 2 people on hardware. Well, I contribute, of course, so in general, there's quite a bunch of people here. And Guido, not to forget, so we have a lot of people involved in the development. And so you could see it as a company where all the different knowledge of all the different fields is together in one company instead of scattered over different companies.
I want to stay with the speakers for a little bit. So one thing I haven't really addressed in these reviews, but is a common concern for active loudspeakers, is that all the electronics are built in, and people go to extreme lengths to isolate components, not just like turntables, but amplifiers and DACs and whatever else from vibrations. But building them into a speaker that by its very nature, like its purpose is to vibrate. What is there? Does that impose a sort of performance limitation on
well,
an
you
active
have
system?
to be aware of it. That's the thing with all of these aspects. You have to be aware of it, and then you can take measures. One important measure, for instance, is, as you notice, the SB1 subwoofer. Some people call it it's upwards firing, so it's moving vertically instead of horizontally. And because it's moving vertically, it can push towards the ground, so to say, because that's the dynamics are vertically, and so it's searching for counterforce in the vertical axis. But it also means that it will not put the vibrations in a horizontal axis into the main system. So the main loudspeaker cabinets will not be driven into vibration so much by the heavy woofer moving up and down. And so that's one of the design aspects in which we really took into account the fact that you have a moving a driver that you don't want to see its vibrations entering the main system. Another thing is that one of the main problems, especially of course with digital converters, is that the vibrations they affect the crystals in the converters. The crystals are very sensitive to vibration. But we were aware of that from the very beginning. So what we do is we take measures by putting the whole vibration sensitive part of the oscillator into a damping material. So it's not affected by the vibration. So it has its own resonance, the crystal, but that resonance is damped by the absorptive material in which it is put. So that's just to name two aspects, but yes, we are aware of that fact, and I should also add that everything is a compromise, certainly in audio. So you could maybe improve the sound by taking out the electronics of the loudspeaker and put it in a separate box and then have the wires to the speaker, but that becomes a really non-elegant system. And people can make mistakes, connect it either to the woofer drive or whatever, or you need very proprietary connectors, and then people complain, I cannot use my special cables. And so it becomes a big story. And we love to offer elegant solutions. And if the electronics is built inside the loudspeaker and we take care of all kinds of aspects that matter for an active design, such as vibration, we believe that we will be at a quality level that is so high that it will be very hard to improve, and that, of course, if there's always space for improvement, putting the amps outside or so, but then it suddenly becomes a non-elegant system, and we believe in elegancy here. So to have just a single box as a source, the MU1 with a built-in room streamer, room server even, and just one cable that goes to the LS1, and then from the first LS1 to the second LS1, and that's the full wiring. Yeah, we love that simplicity and that elegancy, and yeah, that's valuable for us.
In a sense, like topologically, you actually have the electronics in a separate box. It's just that that box is a leg that attaches to the speaker magnetically. But and you have, well, not entirely proprietary connection. Well, the protocol is proprietary.
Right.
It's a 5-pin XLR. But that also means that you can upgrade the electronics. And
Absolutely.
you offer that as a program, right? If you have an older
Absolutely.
LS1 and you want to upgrade.
That's certainly one of the most important things in this company, is that we keep on improving our equipment, both in software and in hardware. And wherever it's feasible, it's not always the case, of course, but whenever it's feasible, we offer the upgrade path to the user. And that happened to the LS1 a couple of times. So LS1 owners could upgrade to the LS1 BE with the beryllium tweeter. Now we have the new version with the carbon tweeter. Customers can upgrade to the carbon. I think that if you have the beryllium, the carbon is not a big step up. However, with the carbon, we also introduced new hardware with new power amplifiers that are of slightly higher quality. And yes, people can upgrade just the electronics. And after the upgrade, their system will be as new. And this is also important for us to offer these opportunities to our customers of the active loudspeakers, because with the active loudspeaker you buy yourself into a closed system, and then if the company then marches on and introduces a new model that's even better in 2 years, you are sort of left behind, and it doesn't feel good because you have to replace everything. And so we really love to keep our customers on board, and we offer hardware upgrades whenever we improve the hardware, and software upgrades whenever we improve the software. And that's actually a very special thing, because we keep on improving the sound quality and the functionality of the software of the LS1s. With the LS1C, we introduced not only completely rewritten controls software, which means that everything that's going on inside the LS1 is controlled by a central processor. Now, that's a lot of software, and that software has been rewritten from the ground up to offer us more opportunities for improvements also in the future. And with the introduction, we also offer a further improved DSP processing of, for instance, that phase correction of the crossover that I just mentioned. Because during the development of our streamers, the MU1 and MU2, we learned a lot about what matters in digital processing. And what we figured is that we could use the same type of knowledge, not exactly the same code, of course, because it's a completely different processor, but to use the same strategy inside the LS1 processing, the DSP of the LS1. And so we developed that, and it was a stunning improvement, especially on that crossover, the phase correction of the crossover. And so this is what we offer to all our customers after we introduced the new firmware that came together with the LS1C introduction. All our existing customers could download the new firmware, which included the new corrections of that phase correcting crossover, and enjoy the difference. And I think that's it's probably special. I don't know how many companies do it. I know there is different companies who offer upgrade passes, but I think that especially with a closed system like an active loudspeaker, that again offers advantages that you cannot have in the analog domain. I think that's, yeah, we feel that we are sort of obliged to do that to our customers, to let everybody enjoy our journey together with us.
And so you have, there are 3 versions of LS1, or 3.5 sort of in production. There's the LS1 version 2, which is sort of based on the original, the LS1A, which is a lower priced version, and then the LS1C, which are the ones I've reviewed, and then the LS1C comes in 2 versions. There's a high max material, there's an option on it. But so the price, even without high max for the LS1C, I believe is €25,700, and it's a lot of money to most people. And then you might be tempted, should I start with a different one and then upgrade? But then the upgrade is probably going to cost you more than the price difference between the models. Like, what is the ratio there? If I buy an LS1 version 2 for like 19,000 or whatever.
I will explain a little bit. You can have 2 types of bamboo finish. You can have a lacquered cabinet, and indeed we have the high max finish, which is high max kind of artificial stone, how would you call it? Similar to Corian. Maybe some people know Corian. For the Corian or the high max, we need the special tweeter that was developed for the LS1C. So the LS1C can come in high max and all the other finishes, and the LS1 Type 2 and the LS1A come in the bamboo versions and the lacquers. Okay, so that's one thing. The other thing is the differences between the three models, the LS1A, the LS1 V2, and the LS1C. And that's actually mainly in the drivers. The LS1A is, you can see it here behind me, has, let's say, a budget tweeter and a budget woofer. Then we have the LS1 V2, who has the high performance woofer and the budget tweeter. And the LS1C has the high performance woofer and the high performance tweeter. And these, especially for instance, the tweeter is developed especially for us, and it comes at a price, so it makes the bill of material, so to say, the value of the components of the LS1C a lot higher than of the other models, and that's reflected in the retail price. So it's not much more margin on the LS1C or so. It's just a more expensive product to build.
So if you would buy then an LS1 version 2 or an LS1A, the one upgrade you can't get is the high-max material because you already
Right.
have a different chassis or
Right.
different body material.
But we indeed, I forgot to answer that, but indeed you are right. If somebody buys the LS1 Type 2 and want to upgrade later to an LS1C, that's perfectly possible. Of course, in total, he will have paid a little more, but it's...
But not all at once.
No, not at all at once, and it's not so much more. It's all sensible prices.
So we touched briefly on converters and the digital side of things, and having a speaker be internally digital affords you opportunities that you would not have in an all analog speaker. Now, my journey with Grimm Audio started last year when I bought an MU2, and because of how its DAC sounds. But that DAC is not in even the flagship LS1C because this speaker was designed before the DAC.
Yeah,
is that right?
That's right. Yeah. And yeah, I can imagine people asking us, when will there be an LS1 with the MU2 DAC? And yeah, we will later this year introduce power amplifiers. And yeah, why isn't the power amplifier in the LS1?
Breaking news, new product from Grimm.
But you have to know that developing a product, a commercial product, is maybe a little more complicated than many people think. It's not just modules that you can Lego together. So projects like that take years. And so, of course, it's clear that we are dreaming of developing an electronic slide for an LS1 in which a variant of the MU2 DAC will be and a variant of the power amplifier that we are introducing. But maybe not. It's like I already said, there's so many compromises always involved that it's not so easy to just take the best of that and take the best of that and the best of that, and then you have the non plus ultra. It's a delicate balance, and so it might not be the case that the best component there combines perfectly with the best component there, and so you have to really be careful and design to a goal. Now, the amount of work needed to make an LS1 style active loudspeaker with the FPGA based electronics that we have in the MU2 and the new topology we have in the amplifier, that's many years of work. And so at this moment we actually decided to first develop a parallel project. So we have the MU1 combining with the LS1s. Of course, you can use it with any DAC, but okay, within the Grimm Audio ecosystem, it's the MU1 with LS1 loudspeakers. And then the parallel path, so to say, internal competition, as we call it, is to have an MU2 with a power amp and probably some passive loudspeakers of a random brand. But what we find, for instance, selecting loudspeakers for the introduction of our power amp at the show in Vienna in June.
The show formerly held in Munich, but they're moving to Vienna in early
Exactly.
June instead this year.
And so we are now selecting the loudspeakers for that introduction, and I can say it's really extremely difficult to find a passive speaker that performs to the level of an LS1C with the motion feedback sub. And then you can say, yeah, but you have the MU2 DAC and you have the new PA1 amplifiers. So that must be much better because they are better than the DACs and the power amps in the LS1. But it doesn't work like that. It's not for nothing that we developed active loudspeakers. They offer you a couple of advantages that are super hard to achieve in the analog domain with the passive speaker especially. And so if people ask me which system would you think plays at a higher quality level, it's difficult to say. Some aspects will be better in the passive loudspeaker system combined with the MU2 and PA1. Other aspects will still be better in the LS1C with the motion feedback sub. And my bet is that will stay like that. So they will both be very beautiful. And it depends a little bit on preference and taste and stuff. But I'm not going to say this is always the best solution because every option, every topology has its own advantages and its own disadvantages. Now, I should emphasize that the amplifiers and the DA converters that are used inside the LS1 are of extreme high quality. For instance, the analog to digital converter chip inside the LS1, because you can connect analog sources. Yes, they will be converted to the analog domain, digital domain, because the crossovers in the digital domain and the corrections of the drivers are in the digital domain. So yes, you need to convert from the analog domain to the digital domain. But that AD converter is of extreme high quality. We still can't find a better chip. And the same is true for the DA converter. It's really of extreme high quality. What matters more for the conversion is the way you use the power supplies, the oscillator, how low is the jitter of the oscillator, all that kind of stuff. And that's with Grimm Audio one of our main focuses. And so the sound quality of the built-in DACs and amps of the LS1 are definitely not a limiting factor for the sound quality that you achieve with this system. Is this the final word? Can we do better? Yes, we can do better. But as I tried to explain, that's a huge project that will take many years.
But speaking of huge project that takes many years, I mean, and also relating back to your comments about everything being a compromise in some way, are there other speaker design principles that you would be interested in? Will there be an LS2 in that case, or like, are there? You don't need to give me specifics necessarily. Like, I'm not trying to get a product reveal out of you, but like, there's so many ways to build a loudspeaker, and I'm sure a curious, technically minded person is at least slightly tempted to explore some other types of designs.
Yeah, you bet, of course. Well, the main thing is that the acoustics are the most important thing to take into account. Whether you are designing a passive loudspeaker or an active analog speaker or an active digital speaker, digitally controlled speaker, it doesn't matter really. It's speaker design is about the acoustics. And so we always look at not just at the on-axis response, but the off-axis response is of extreme importance for us. So that you can look at it as the response to the sides. So how will the first reflection sound? Also vertically, how will the reflection from the ceiling or the floor sound? But also if you average out all directions, that's called the power response. Um, that's what causing the sound in your room if you take a listen to your speakers from a distance. So the reverb, so to say, in your room is defined by the power response of the speaker. Um, and everything needs to be good. So the direct sound needs to be good, and the power response needs to be good, and the first reflections need to be good. And but there's more roads to Rome. So what we did with the LS1 is we said, okay, we want to have a speaker that has a wide dispersion. And then because we make a wide baffle, we have over a wide frequency range a radiation pattern that is, let's say, hemispherically. So we cut off the radiation to the back and we keep the radiation that's going to the front. And that offers all kinds of advantages, like the energy that's going to the side is already also attenuated. So if you then turn the speakers more toe in, you are attenuating the first reflections on the side walls, and maybe the later reflection on the opposite wall will be louder, but that one comes later and has a different perceptive effect. It doesn't interfere so much with your stereo image. So it's a big advantage if you want to have a very precise stereo image to have a wide loudspeaker baffle and then toe them in a bit more than people are regularly doing. Now that's all because of the acoustics, the acoustic qualities of the design. Now there are more options to reach a good design. You can think of a dipole, for instance, with an open baffle. You can think of a loudspeaker that's more or less omnidirectionally radiating over a much higher bandwidth than a standard loudspeaker. Since with a standard loudspeaker with a standard width of the baffle, you will be projecting hemispherically, so just to the front, upwards from, let's say, 600 hertz, and below that you're radiating more to all directions, which means that the first sidewall reflection will have more lower frequency energy than higher frequency energy. So the lower mids are already in that reflection, whatever you do with the angle of the loudspeaker. And since you want that first reflection to have a similar color as the direct sound with a narrow baffle loudspeaker, you probably don't want to do so much toe in. Whereas with the LS1 you can do it because the first sidewall reflection will be attenuated over the whole frequency bandwidth from, let's say, 250 hertz, and that's the part that matters for your stereo image. But yeah, you can also just as well say, okay, let's make a loudspeaker that has a more omnidirectional response, and it will sound more spacious because the reflections become louder, and that can also be for the taste of a certain customer, exactly what he is looking for. And you can do that right too. It's so you make a fundamental choice in the radiation pattern, and then you have to make sure that the speaker behaves optimally for that acoustic choice. And of course that's difficult, but you have your goals. And so if you now say, will there be another loudspeaker from Grimm in the future? Well, to be honest, we don't know. And to be very honest, yeah, well, of course we are experimenting and thinking about different solutions because it's fun, but it's not where our main development is at the moment. First, we want to have the amplifiers finished, and there's other stuff cooking. But yeah, it's an interesting problem, a loudspeaker. It's always tempting to think of new solutions.
Sort of related to that before we get into some other stuff, or actually, first I want to ask, because of one thing you didn't mention now about the acoustics of the speaker is the rounded corners and how that mitigates diffraction.
Yes.
Because it's my understanding and this is what I'm saying in the review, so I hope this is now correct, because otherwise I need to go back and edit it. But that, because you get diffraction when the wavefront reaches the edge of the speaker. If that is a sharp corner, that now creates a secondary wavefront, or which is the diffracted wavefront. And the wider the baffle, the longer it takes in time before that diffraction gets going, which means that you get more time smearing from diffraction on a wider baffle. But you get the directivity.
And also more dependence on the angle. You also get more dependence on the listening angle. Because if they're very close to each other, you get a certain color, but the color is relatively independent of the angle where you are sitting. And so if the distance to the diffraction is larger, it becomes more dependent where you are, what the color of the diffraction is. And actually this is a method of the hearing brain, the brain system. You listen more with the brain than with the ears. How it determines your acoustic environment. You can hear the size of the obstacles around you. You can hear the size of the musical source. And also you can hear the size of the loudspeaker. And the problem, of course, is that if you record music and the source has a certain size and the information is in the recording, because it's a proper stereo recording, la la la, then you don't want to have the acoustic properties of the loudspeakers be put on top of that and be dominant over the acoustic information that's in the recording that tells your hearing system what the source is that you are listening to. And that's a little bit a problem of the narrow baffle loudspeaker. It's like with my head. If I talk towards somebody, the higher frequencies of my voice are projected towards him. But since the higher frequencies don't bend so well around my head, if you're listening at the back of me to my voice, it will sound much duller. You will not have the upper frequency range so much, and it's the consonants that have the higher frequency. So it's less easy, it's less intelligible if you're listening on the back of somebody instead of on the front of somebody. Now, where is that frequency where it starts bending around my head? Well, with the size of a human head, that's about 600 hertz. And so if you would have a monitor with the size of a human head and you play a closed mic recording of a human head, it may sound pretty natural. But as soon as you play a much larger instrument, let's say an upright bass, through that speaker, it sounds a little bit as if a human head is mimicking the sound of an upright bass, if you get my drift. And so you sort of hear the acoustic properties, not just of the original sources, but also of the loudspeakers that you are using to replay the recording. So what we were looking for in the LS1 is to have a loudspeaker that has less of an acoustic signature, and therefore we ended up with a wider baffle. And of course, if you have a wider baffle, it means that any wave that's traveling over the baffle of the loudspeaker that will reach the edge, it will break there, and you will have a secondary source. It's called diffraction, and that will kind of offer again cues to the hearing system that this is a source of a 2 feet wide loudspeaker, and so it betrays itself again. So you want to make certain that the edges are rounded to kind of hide the sonic character of the loudspeaker. And since that mainly matters for higher frequencies, and we have a tweeter that's with a constant directivity waveguide that spreads out energy wider than with a standard tweeter, we have to take care of that edge diffraction a little more. And that's also why we have the edge at the bottom here also rounded, and the tweeter is at the bottom. Of course, at the top, which is the side of the woofer, we didn't round it, but it's also because the speaker becomes quite ugly if the top is rounded. And you don't see the impact of a rounded edge there so much because the woofer is also in between, and that also offers the diffraction effects of that hole in the cabinet, which is unfortunately a little bit unavoidable because any other form of driver will be less stable, and so start to distort at lower frequencies. So we are sort of stuck with the way that drivers are regularly built. But at least it doesn't. It means there's no need to round the top edge as well, and that's also why the tweeter is at the bottom, because it's nice to have a flat top part.
But can you look at a sort of boxy orthogonal speaker and not go ugh? Or do you judge them prematurely all the time?
It's a good question. Well, I try to always stay open. I like to be surprised. So if somebody does something that I think, oh, I wouldn't do that, I stay curious and listen. But what I always do with speakers like that, let's say a large rectangular box, so I immediately put pink noise on the speaker before listening to music or whatever, just pink noise, and then listen to it and move your head, and immediately you will hear all kinds of comb filtering problems that are partly caused by the driver, partly caused by the crossover, and partly by the edge diffractions. And yeah, if you do that on the LS1, it will be very smooth. And that's what I'm looking for, that the sound color of a pink noise doesn't change so much if you change the angle. But with many speakers, unfortunately, it's quite a mess.
Back a little bit to the opportunities afforded by an active speaker, and specifically with the digital crossover. There are lots of things you can do, and there are many brands now that add a lot of features. You have not gone all the way on all the potential features, and I believe one reason is that you don't really like trying to solve room problems with DSP. Is that right?
That's right. Yeah, so as soon as people add DSP to a loudspeaker system, they immediately start indeed adding very, very complex equalizers to counteract the influence of the room on the response at the listening position. Well, there's two things I would like to say about that. The first thing is that it's just impossible to compensate every single reflection that enters your hearing and at the listening spot, because you are moving, the room is changing, the temperature is changing, somebody opens the door, the acoustic environment is continuously changing, and your head is continuously changing in position. So just putting a microphone there and do a measurement and compensate for everything that you measure, that doesn't make sense at all. Now, then you could say, okay, I put a microphone in one position and another, maybe 5, 6, 7 positions, and I average out the differences, and that's what I will use for my filter. But then there might be a problem in one position that's totally not present in the other position, and now you are adding part of the compensation of the other position to your first position. So you're messing up position 1 just to make position 2 a little better. And the thing is that you know that room, you live in that room. So some of the aspects your brain can get rid of. It's also, there's a thing called the cocktail party effect,
Yep.
and you analyze the signal over time. So you analyze the first arrival, you analyze the early reflections, you analyze the later part of the reflections, and you can kind of separate all of them in your brain, and so you know what the direct sound is like, even if it's
I got a
then
visitor here. My dog.
if
Oh, she left. Okay, sorry. The
no
cocktail
problem.
party effect, yes.
Yeah, the cocktail party effect means that you analyze the sound scene, so to say, in blocks of time. So you have your first part, which is the direct sound, and you can listen to that separately from the earlier reflections and from the later reflections. And so you can hear that the early sound is linear, even if the later sound colors that sound. So I'm not in favor of averaging out all those reflections and then trying to make one average response out of that, since then you're messing up every single part of it, because there is no, as soon as you start moving, everything changes in that in all those aspects, and so it doesn't work. Now, okay, you can say, okay, if we know that, let's not touch anything above 200 hertz. So we keep the complete phase response and amplitude response from the speakers as it is above 200 hertz. We only change the room mode part, which is below 200 hertz. And then sometimes you might be successful with that, I agree. But sometimes it's just different. And the main problem I have is with that is the second part of my, the second point I wanted to make. The second point I want to make is you have to understand that we EQ the drivers to a sort of linear response. It's not completely linear, because we know that we have to be extremely careful with adding EQs. So by adding an extra EQ band, we already know that there will be a penalty in sound quality. If we raise the Q too high, the sound of that EQ will be more problematic than if the Q is low. So we developed software here in the house to calibrate every single speaker that we produce and make it perform as flat as possible, but not flatter than is sensible. And so we learned what to do and what not to do. We put all that knowledge in a piece of software. The piece of software calculates thousands of options of equalizer settings with the goal to minimize the amount of equalizer bands and to minimize the Q factor. And so we aim for the simplest solution to still achieve a quite flat response. Now, if you know how far we go into this and how much we have improved still that technique in the past years by just changing small details in it, and if you then compare that with just putting up a microphone and pressing a test button and then trusting that the EQ that comes out of that will solve everything, that just doesn't fit together in my mind. So I'm always very careful with adding equalization to a digital audio system. That being said, sometimes you just bump into a problem that's seriously annoying, that you cannot solve by relocating the loudspeakers, that you even cannot solve with the LS1s by taking off the sub of the footplate and putting the subs in the optimal position for the frequencies below 70 hertz and leaving the main system at the optimal position for your stereo image, because that's, in my opinion, the best way to deal with room acoustic problems. And I should say, of course, you don't have the opportunity to solve the room acoustic problems with applying acoustic treatment. You can do that passively, but there's also active absorbers on the market that you can use that are smaller and still very effective. If you don't have all those options to help you out of this problem, and you still need to solve an annoying hum or bump in the low frequency response, because a suck out you can't solve in any case, but if you have an annoying amount of audio power in a certain frequency band, you could indeed apply an equalizer to that. And I'm not against that at all. But the problem is that to do that right, you need to have a very powerful analyzer. You have to know what you're doing. You have to do all kinds of measurements in the room. And then you think, okay, we need one band at 50 hertz and one band at 30 hertz with the Q so and so, and just check it and be done. But then you are approaching this problem in a professional way. And I'm never against a professional approach.
All right, that's a pretty good summary. Because there's a lot of people who seem to think of DSP as a panacea. Like, of course, everyone should be using it always. And if you're not, you're falling behind. You're an audiophile dinosaur stuck in the past. The future is all DSP. Maybe the future has some DSP in it. I mean, your speakers have DSP. It's just that it is about how it is being utilized. To your point, like about doing it with care, then, right?
Exactly. Yeah, we might add a parametric EQ to the LS1 in the future, but so far we didn't do it because it's a dangerous tool. You can mess up so much with it, and in the hands of a professional, it's a really powerful tool. But you really need to know what you're doing, and then you could say, okay, for the consumer, you can add some automatic measurement system, and there's companies who offer the automated solutions. But the problem is almost always, in my experience, way too complicated for a generic solution that you can simply automate. So we are aiming for the best sound quality and not for something that's good enough. And yeah, that can be a little bit stubborn maybe, but we believe in that approach.
And so speaking of digital processing, then, one thing that, I mean, I'd like to think I have a decent grasp of like digital audio, but one thing that was a little bit tricky for me to wrap my mind around is the noise shaping that you were talking about in the DAC design of the MU2. So do you have, I mean, you being a teacher as well as the proprietor of an audio company, explain it like I'm 5, noise shaping in digital audio.
Okay, I'll do my best. So yeah, what you need to know is that, let's stay in the digital domain. So in the digital domain, you have a couple of bits, as you know. CD had 16 bits and the sample rate of 44.1. But okay, so we have 16 bits. Now for every bit that you have, that you add, you will have 60 dB more signal to noise ratio because you have more space to define the signal. If you have 2 levels, so that's with 1 bit, so I should do it like that, your signal will be very simple. If you add more bits, you're approaching the original analog signal more, and since there is less distortion involved, you have less noise, because we are talking about signal to noise ratio, but in digital you should say the signal to distortion ratio in a way. Now there is a way to make the distortion mathematically work as noise. It is not distortion anymore. With Dither, you can see that the distortion goes away, the quantization distortion as it's called, and we have just noise, but it's still connected to the amount of bits that you are using. So, okay, so with more bits we have less distortion, or in other words, we have less noise. On CD we had 16 bits, which is 65,000 something levels, so we are approaching the analog signal quite well. But to turn that signal into the analog domain from digital, you have to then use the 16 switches, so to say, that all have a different voltage, and the voltage of the smallest bit is only, that switch is only switching very tiny voltage differences. Now the largest bit, most significant bit, needs to have the exact same precision as the smallest bit, otherwise it doesn't make sense to add more bits, because the resolution will then be determined by the most significant bit. So the precision of the most significant bit becomes a big problem. Now in the 80s already, at Philips, the engineers realized that this is a challenge, because to reach that precision, you either need to select the chips after the production, so you can throw the majority away, or you have to, with lasers, trim the resistors in that multi-bit DAC topology. So they thought, okay, if we want to make this mass market, we have to find a better solution. And so they developed what's called bitstream. And the idea behind bitstream is as follows. In the digital domain, you're going to recalculate the signal from 16 bits 44.1 to fewer bits and a much higher sample rate. And by doing that, of course, it's easy. If you have fewer bits, you have a higher noise. I just explained that the noise was related to the amount of bits. So with less bits, if you convert it from more bits to less bits, you have more noise. But because you are with a higher sample rate, there is a higher bandwidth in which you can put all that noise. You will have less noise in the audio band, because originally with 44.1 all the noise was in the audio band, because it's going up to half the sample rate, which is called the Nyquist frequency, 22 kilohertz. But if you run at a much higher sample rate, let's say 64 times 44.1, so we are at 2.4 megahertz or so, then you have much more bandwidth, up to 1 megahertz, to store that noise. So if the noise is spread out over all frequencies equally, in the audio band the noise goes down just because of using a higher sample rate, even if you have just 1 bit.
Yeah, because you're spreading the same amount, but you're spreading it over a bigger surface. You have a bigger sandwich for your butter.
Exactly, that's how it goes. Now, the problem is that you are still not there. So you could say, well, okay, we then limit ourselves to, I didn't do the calculation, but let's say 10 bits, or 8 bits, let's say 8 bits, half of the amount of bits. And then the noise is low enough. But then you would still need a very expensive production method, and also 8 bits running at 2.5 megahertz is a lot of data. And so especially at the time, the chips weren't capable of doing all the calculations for that. So they decided to go just for 1 bit. But for 1 bit you need an extra trick, not just spreading out the noise over a wider bandwidth. And that trick is called noise shaping. And what it does is, in the conversion process, where you throw away information of the 15 bits that you will not be using, and you have just 1 bit left that you will keep, well, all the information that you throw away, that 15 bit, you use that information again for the next sample. And the good news is the next sample is coming much quicker than on the original 44.1 kilohertz sample rate, because you have 2.5 megahertz sample rate. So you have 64 samples within every standard sample of the CD. So you can say, okay, we throw away 15 bits, but we add part of that to the next sample. And so where first the bit was pushed up a bit, now it might be pulled down. And because of the information that's fed back to the next level. So you are continuously using the information that you are throwing away to nudge the one bit that you are keeping.
Because in one bit, you're essentially doing a square wave, because it can either be on or off.
Yeah, but it can be on or off at a very fast pace. So let's say...
Exactly, but then some might have been on, but because of the borrowed 15 bits or whatever from the previous sample, it now might average to, it should be off instead.
Right, exactly. So what it means is that maybe it makes it more clear. Let's say the result that you're aiming for is halfway the level of the plus voltage and the minus voltage of your 1-bit signal. And you want to be in the middle, at 0 volt. So plus 1 volt, minus 1 volt, and you want to be at 0 volt. What can you do if you can only be at 1 volt or at minus 1 volt? Well, what you can do is you can say, okay, I'm now going up, stay there for half the time, and then go down and stay there for the other half of the time, and average out over the full length of that, I will be on average in the middle.
Yep.
And so,
and then if you do that
with just
64 times or more times the original rate, then you can get to average a value that represents the original full dynamic resolution.
Exactly. So that's what you do. So you average out the plus and minus levels of the 1 bit. So it stays high or it stays low, lower or longer, dependent on what you want to achieve over a longer period of time. But the longer period of time is just our 44.1 sample rate, so to say, because we have so many intermediate samples. What you are now doing, feeding back the samples that you throw away. The samples that you throw away are effectively the noise. That's the information that you're quantizing, that you're throwing away. It's so you're using the distortion, feeding it back. And in this feedback loop, the effect is that you are averaging out the information, and that effectively means you are filtering. And the filtering means that in the audio band, so on the longer term, from the perspective, of course, of the super high sample rate, in the longer term, you're pushing down the noise, and in the shorter term, you're letting the noise go up. And that's a shaping of the noise. So pushing it down in the audio band and letting it go up above the audio band. That's a shape of the noise. So the average noise stays the same. It goes down in the audio band, it goes up above that. So it's a different shape. And that's why it's called noise shaping.
The MU2 then does that in sort of extra elaborate way. Well, first of all, it's the 1.5 bit that you're using instead, but then also an 11th order noise shaper. Could you explain what is the order? What does that represent in terms of the noise shaping?
Well, the order, you can say that, look at that as how far do you push the noise down in the audio band, and how quickly does it rise above it, and where does it rise? Of course, you need to define that, but well, you can push it down a little bit, but you can push it down more. You can push it down really far, and the higher the order of your noise shaper, the more you push down the noise in the audio band. And of course, the higher it goes up above it. But we don't hear that, and also we apply analog filtering behind the DAC to get rid of all that ultrasonic noise.
Yeah. It is computationally intense, right? Like it takes a lot of compute effort to do this, because you're mentioning, like Philips in the beginning, at the invention of bitstream, they had to go to 1 bit because of the sort of computational horsepower at their disposal. But what you can do now in the MU2 goes beyond that. Am I right?
Yeah, you're right. But of course, now with the current horsepower in processing, you could say, well, we can do more bits in the noise shaper. So why stay at 1, or in our case, 1.5 bit? The thing is, just as in the early days, the more bits you use, the more processing power you need. And if we then turn that around and we say we have a certain amount of processing power, and it's a lot, but it's still limited, what happens if we apply that to the least amount of bits, so it's the least demanding on that processor, and then we use the full power to derive the best possible resolution from that process. Then we probably have something that sounds better than if we use the exact same processor to calculate for more bits. And so then the question became, with how few bits can we achieve the best result? And the best result, with that I mean, with 1 bit there is a problem, and that is called noise modulation, which means that the noise that you get in the audio band, but also definitely above that, so the noise in the system, is dependent on the signal. And that's what you don't want. You want to have the noise be always at the same level, so no noise modulation in level. Now with 1 bit, it's mathematically, you can prove that it's not possible to solve that problem. And that's one of the bigger problems of DSD, that it's by principle, it has a problem. So we figured, how much would you need to solve this problem? Is it 2 bits? Is it 3 bits? And then with 1.5 bits, so to say, it's not 2 levels but 3 levels, where 2 bits would be 4 levels. Now with 3 levels, our people were already able to solve this mathematical problem. So that's why we call it 1.5 bit. It's 3 levels. It's not 1 volt, 0 volt, -1 volt. You could look at it like that, but it's in the time domain, pulse width modulation it's called. So we have a short pulse, we have a wider pulse, and we have a much wider pulse. That's the differences we have, and that's different than with just 1 bit, where you have just 2 options in pulse width.
In our first attempt at this interview, I think I made some feature request to you that you shot down. So I won't bring it up again. I'm going to try a different feature request for you this time, and that is, which could also apply to the LS1 control software that you can run on a computer and connect straight to the computers if you don't have an MU1, and that would be presets for some sort of EQ. And now I know we talked about DSP for correcting room modes and so on, but you might have, maybe you want a rumble filter for vinyl, maybe you want a late night listening preset to turn down the bass, or you might want a Fletcher Munson curve thingamajig for, various purposes. So I'll just plant that seed with you now, and well, either you can shoot it down or you can bring it back to your team. I think I would appreciate having that, because that is an opportunity that you have in internally digital speakers. They could all theoretically do this, but quite few of them allow the user to have some sort of preset like that. And I'm not talking about parametric EQ, because you're right, a high Q, so a pointier change in the sound versus a low Q, which is shallower slope. Yes, you can mess things up, but I think you could offer a dumbed down interface enough that the user can't really destroy anything, but that you could toggle for movie mode or something like that.
Yeah, well, there are kind of presets already in the MU1 where you can say, okay, I got this television set, and it's connected to the Toslink input, and if I select that, you can automatically go into a low latency mode of the LS1, because the phase linear crossover that I mentioned before comes with a penalty of some latency. It's about 1 frame in a video system. You can automatically have that turned off. The sound quality is a little less great, but at least you don't have the lip sync issue. So that kind of preset. The preset that you are demanding is actually already available in the LS1 control software. So if you don't have an MU1, but you use an LS1i USB interface, or even the USB control dongle that we have, you can run our software on a Mac or PC, and it offers you exactly those presets. When we will add features to the future firmware updates that are interesting to memorize, for instance, EQs like we just talked about. It will make sense to add a preset style options to the MU1 web interface as well, and I think it's a good suggestion. So yeah, I will think about it.
But you have some other stuff planned, right? I think you mentioned like going into sleep mode, synchronizing the MU1 and the speakers and things like that.
Right. That will be. We are still working on the LS1 firmware, and there's a release. I hope still before summer. That will, among other things, also offer us a standby function where the LS1 goes into sleep together with the MU1. But it will only work with the new hardware that was introduced with the LS1C. And of course, if somebody upgrades his hardware, he will also have that function.
Yeah, and then the downside, I guess, is a feature that I end up using a lot, as recently as today when I was out walking the dog. That's Rune Arc.
Yeah.
Because if you set the system to sleep mode, Rune Arc stops being available.
Yeah, I think that we offer a Rune server inside the MU1 and MU2 since we believe in the elegancy of a simple system. But now the system is also Rune ready, and so it's open to all kinds of other solutions. You can stop the internal Rune server from running where the Rune ready endpoint is still available. And then, of course, you can run Rune on a PC or Mac or a NAS or what you have. And then you have all the possibilities that Rune offers. And also maybe you have a catalog of 100,000 tracks or even more. And then Rune recommends to have a more beefy computer. Yeah, that's not inside the MU1, MU2. I think it's a lot of tracks. I hope you live long enough to listen to all of them. But
do you think I have time to listen to these records? Plus my digital?
Yeah,
that's not how us audio people work. Like we're hoarders. Who was that Nobel Prize literature Nobel Prize winner? Umberto Eco, is he the one that said that books are like medicine? You buy it in case you need it later. And I think about records like that way sometimes. Like, this is probably something I'm going to want to listen to someday, so I'll have it ready for when and if that comes up. But yeah, like I will mention this too to get back to your point about now the standby mode and how the MU1 is now also Rune endpoint. That is actually how I reviewed the system, because I have my Rune, and I'm trying to learn to not say Rune core, Rune server set up on my MU2. So I didn't want to migrate my whole library for the testing.
Of course.
So
yeah.
I just use the MU1 as an endpoint, which should not make a difference in whether it would stream internally or receive the data from the MU2. So I can verify that works properly on this firmware.
Thank you.
But yeah, that's actually all the questions I had. I can see I see the box with the speakers and it's all packed up and it's getting picked up Monday. But I had a good time with the system. You have not seen the review. I just want to clarify that you still have no idea what I'm gonna say in the review.
I'm very curious.
Well, but one thing, when we, on a first attempt on this conversation, that we messed up the audio on, one thing that you mentioned without prompting from me is that, and I think maybe I was asking about like, is technical perfection always desirable? And one thing you said is that, well, you might want a different system because any system is inherently compromised, and you might want a different way to play back music that isn't striving for that perfection. And I mentioned then that I'm saying basically the same thing in my review. So lastly on that, and sort of almost touching on feature requests and also on the DSP and all the voicing of things. Oh, and the EQ presets that I mentioned for my wish list, is that something that you would be curious to explore, like a deliberate voicing, not for room problems, but for like character or coloration, deliberately or not, like
Well,
deviating from strict linearity on purpose?
well, the thing is, in my experience, I actually just explained my students last Wednesday that you need a linear speaker to make mix and mastering decisions on. Otherwise, if the speaker is not linear and you know it's not linear, let's say it's got a little bit too much of top end, you will compensate for it because you know you have to make it a little brighter, your mix. But you will, what I learned from mastering engineers is that you tend to overcompensate. So you will have even more top end than you should have added. And so I know from a mastering engineer, if he listens to his old work, he can immediately hear on which speakers he made the master, because he hears the sound color of that speaker in his master, because it's
It gets baked in. Your decisions are made through that interface, through
exactly
those speakers.
exactly, and that's interesting because he's then not listening to his master on that speaker. He's just listening to it on any other type of speaker, but he can still hear that quality. And that means that, in my opinion, the only real solution for mixing and mastering and also for enjoying music is to have a speaker that's as linear as possible, both in the direct field and in the reflected field. However, and this is what I taught my students, there's often a compromise in achieving a linear speaker, and the compromise can have a musical or a sonic impact. And so it becomes an extremely difficult challenge to have a speaker that's both linear and very musical, and that's not tiring to listen to for a long time. There are speakers on the market, especially in the pro audio world, that are very linear and you can make a real good mix on it, but at the end of your working day you are very tired and you would never want to have that speaker at home. And there are also speakers that are very enjoyable at home, but you cannot play all kinds of music. It does well with classical or it does well with blues or whatever, and you then tend to play that style of music. But if you play that music, it's very enjoyable, but you would never be able to make a mix on those or to do a master on those. And what we at Grimm Audio really want to achieve is to have the best of both worlds. To have a speaker that's very transparent, not just because you hear all frequencies in the right way, but also because, as we call it here, it's emotional transparent. So you hear all the intentions of the artist. And I can confess that this is a very difficult task to fulfill. I believe we are doing better every year in reaching that goal. And I think this is maybe our niche, but I hope that it's inspiring to other manufacturers to also go down that route. Because I wouldn't want a speaker at home that is limiting my musical taste, because I am an omnivore in music. I love all kinds of music, and I don't want my speaker to limit me to certain styles. And but at the same time, we almost everybody here at the company, especially the founders, grew up with discovering the virtues of tube amplifiers and horn speakers and at least high efficiency speakers. And we loved that experience. It can really convey the emotion of the music, of the performance, of the composition so extremely well that we would never want to live without that. And so that's absolutely a reference for us to have. And we routinely listen to high quality tube equipment just to memorize what that was all about, and to achieve as much as possible from our analog and digital techniques that we develop here. So it's not just focusing on linear or believing that digital or DSP can solve it all. The contrary, we are very aware of the problems that analog has and the problems that digital has, and we try to solve them all. And of course, there is never an end to that. There's always a new problem to solve. But we keep that reference. And yeah, I indeed, last time I told you that why not have just two systems? One that's for the hobby to enjoy changing cables and amps and everything, and but it doesn't always sound very good. And then have a system like the LS1 that always performs fantastic, but might be less of a hobby because it's closed. And I know of customers who do exactly that. They have the LS1 system in their living room and they have a hobby system in a man cave. So yeah, it's a very viable option.
Well, I think that's an excellent sort of point to wrap up on, the overall philosophy of Grimm and the objective of your products. So thank you very much, Eelco, for your time, times 2, because we had to do a second attempt. Apologies for that. It's Friday afternoon, so have a good weekend, and maybe I'll see you in Vienna.
Well, I bet we will see each other. Looking forward to that a lot, Ola.
Sounds good. All right. Thank you so much.
Bye.